Assalamu alaikum and hello everyone. This is our video presentation on application of matrices. Many of us think matrices are difficult or not useful, but actually they are used in many areas around us, like in Google search, games, machines, even in hospitals. In this presentation, we will show some interesting real-life uses of matrices. In electrical engineering, we often work with circuits. In complex electrical circuits, engineers use Kirchhoff's laws to form equations for unknown currents or voltages. These equations become a system of linear equations. Matrices make it easier to solve multiple equations at once. Circuit simulation tools like LTSpice or MATLAB use matrix methods to give accurate results fast. In computer graphics, matrices are used to move, rotate, or zoom objects. If you play a 3D game or watch animation, remember, matrices are working behind the scenes. They help in building 3D models and camera movements in a digital space. Every image is made of tiny pixels, like a grid or matrix. To edit or improve an image, we use filter matrices. Filters help to blur, sharpen, or detect edges in photos. This is used in face detection, medical imaging, and mobile cameras. In machine learning, computers learn from data. The data is stored in matrices. Neural networks, which are the brain of AI, use matrix multiplication to learn and make decisions. It is used in self-driving cars, voice assistants, and many smart tools.
Application of matrix in computer graphics. Transformation of objects. Matrices are used to perform transformations like translation. Translation means moving an object. Then scaling. Scaling means resizing an object. Then rotation. Rotation means turning an object. 3D graphics. In 3D environments, metrics help convert 3D coordinates into 2D screen coordinates, and it's called projection. Efficiency. Multiple transformations can be combined into a single matrix using matrix multiplication, making rendering faster and more efficient. Application in engineering. Electrical engineering we used in circuit analysis, example nodal analysis and mesh analysis to solve for voltages and currents. State space analysis of electrical system involves matrix to model dynamic system. Control system. State space representations of system use matrix to describe systems of differential equation. Stability, controllability, and observability are all determined through matrix operations. Robotics and kinematics. Matrix handle rotation and translation in space using transformation matrix. Application in physics. Quantum mechanics. Quantum states are described using vectors, and physical observables like momentum and energy are represented by Hermitian matrix operators. Matrix mechanics. Heisenberg's formulation uses matrix to describe the behavior of particles at quantum scales. Classical mechanics. In systems with multiple degrees of freedom, matrices are used in Lagrangian and Hamilton matrix mechanics. Mass and stiffness matrix describe vibrational system. Electromagnetism. Maxwell's equation in certain formulas like tensor form in relativity involve matrix. Application of matrix in cryptography. Classical cryptography. Working a key matrix, usually a 2 into 2 or 3 into 3 matrix, is multiplied with a vector of plain text letters converted to number. The resulting vector is then converted back into letter, formatting into ciphertext. Matrix transformations in modern cryptography. Metrics are used in linear transformations. Linear transformation in block keepers. Diffusion to spread plain text information across keepers, making patterns less obvious.
Hello everyone. Today I am going to talk about the real life applications of matrices. We often learn matrix operations in mathematics, but many of us don't realize how useful they are in practical fields. When we have only two equations and two unknowns, it's easy to solve using simple methods like addition or subtraction. But in real world problems, we often deal with many variables. Here, we imagine a system with 10 equations and 10 unknowns. Solving this manually is difficult, so we use matrix based methods to simplify and solve these complex systems. Airports use large data systems to show flight times, gates, and delays. All this information is stored and managed using matrices. This helps update hundreds of flights quickly and accurately. Telecommunication systems use matrices to route signals between different towers and devices. Each connection between towers can be represented in a matrix format to track signal flow, strength, and availability. This helps in efficient network management, especially when millions of users are connected. Okay, let's assume there are four small cities in a big city A, B, C, and D. Now, some information about the trains running in these cities is given. A has a direct train to B and D, but not to C. B has a direct train to A and D, but not to C. C has a direct train to A and D, but not to B. D has the trains to A and C, but not to B. Based on this information, a matrix can be drawn to better understand the train connectivity. In conclusion, matrices play a crucial role in solving real life problems across different fields. This shows that the concept of matrices it's not just mathematical theory but a powerful tool in modern technology and communication.